So we are working on product of trig functions and their powers. This is an example where we have tangent and secant functions product, but tangent has odd positive power. Okay. So this is a special case when tangent has odd positive power. If that is the case, the technique is you split it such a way that one tangent x and secant x is saved and everything else you can split it up. Okay, so tangent cube x, I split it into tangent square and tangent, and there was a secant x. So I want to hold on to one tangent x and secant x, and remaining tangent's power I want to replace it by the formula tangent square x is equal to secant square x minus 1. This is the trig identity which you've learned in pre-cal, which was secant square x minus tangent square x is equal to 1. Using that, we are coming to here. So we will replace tangent square x by secant square x minus 1 times this we will hold on to. You will see in a minute what does that do. Now I'm going to u sub my secant x. When I do that, du, the derivative of secant is secant x times tangent x. Now you see we kept that here for the purpose which is already there, so that can be now converted into du. So my integral is secant x is u square minus 1, and this whole thing is replaced as du. This converts into a simple integral, which is u square's integral is u cubed by 3 minus 1's integral is u plus c, and we put u back. That would be secant cube x by 3 minus secant x plus c. This should be your final answer. Okay. So let's practice one more of this kind. Another example when tangent has odd positive power. We said we will peel one tangent and one secant. This is going to be looking like tangent 4x, one tangent x separate, and this is going to be looking like secant square x and one secant x separate dx. So I am peeling and saving one tangent and one secant separate. Everything else is same, right? I'm not changing the question. Okay. This tangent power 4 can be written as tangent square x is power 2 secant square x. Our goal is, except for this separated thing out, everything else should be in secant square format. So we have our rule which says tangent square x is secant square x minus 1. We are going to use that to replace this part. Secant square x minus 1 whole square times secant square x times this remaining part which we are saving as is. Now we can use u sub method by putting u is equal to secant x. So differentiating du will be secant x tangent x dx. So this part is du. In place of secant, we have u square minus 1 whole square. Secant is u square times this whole thing is du. We can open this square using our rule, which we know is a minus b whole square is equal to a square minus 2ab plus b square. That's our college algebra rule. So this will become a, this will become b. u4 minus 2u square plus 1. Outside we had another u square du. which is gonna multiply inside with everything. u6 minus 2u4 plus u square du. Now we can integrate it using the power formula. U the power 7 by 7 minus 2u5 by 5 plus u cubed by 3 plus c. And u everywhere has to be substituted back to secant x. So secant 7x by 7 minus 2 secant 5x by 5 plus secant cube x by 3 plus c. Here is a special case. When we have not tangent times secant, it's just tangent the power 5. Okay. This is done a little differently. I'm going to do this example. Tangent power 5, it's an odd power. I'm going to write it as tangent 4x times tangent x dx. Tangent square can be written as secant square x minus 1. So this thing can be written as secant square minus 1 whole square. Okay, because secant square minus 1 would be tangent square times power 2 is tangent 4 times tangent x dx. We can open this expression using a minus b whole square, a square minus 2ab plus b square. So this will become secant power 4x minus 2 secant square x plus 1 times tangent x dx. Now each of this tangent have to be multiplied with each of these things separately. Secant 4x tangent x dx minus 2 secant square x. If you notice, I'm just separating the integral because each of them is a different kind of integral. Now this problem looked very simple in the starting, but this has split into 3 different kind of integrals. Let's look at the first 2. They are a special kind when tangent has odd power. See, both of them have power 1. So these both can be done with our technique which we've been learning. Secant cube x times peel 1 secant x and save 1 secant tangent minus secant x peel, because tangent power is odd, 1 secant x tangent x separate. Now this one is a little different. I'm going to write it as sine x by cosine x dx. Okay. So let's work on this first one. For the first part, we are gonna u sub as u equal to secant x. If we do that, du is secant x tangent x dx, because the derivative of secant is secant x tangent x. So let's try to write this part down. Secant x is u, so this is u cube, and this whole thing becomes du minus 2. Secant x is u, this whole thing together becomes du plus. For this part, I'm going to make a different u sub. Let's write it v, so I don't want to confuse. V, I'm going to sub as cosine x. Then dv would be negative sine x dx. So you see sine x dx is already there. That becomes sine x dx. So sine x dx would be equal to negative dv. So what I'm trying to say is that this integral sine x dx becomes negative du. So this is negative. And 1 by cosine u is v now. 1 by v. Okay. Let's write this integral out. U cube's integral would be u the power 4 by 4 minus 2. Here power is 1, so it becomes u squared by 2 minus, this is 1 by b. If you remember, the integral of 1 by x dx was natural log of x plus c. So this would be natural log of v plus c. We always need to sub back. U is what? Secant. So secant power 4x by 4 minus this 2 just cancels. We just have secant square x minus natural log of v is what? Cosine x. That should be your final answer. Now you notice one different kind of problem here for the tangent. Okay,